right. So welcome back to the final session of the speakers on DSPT Day. So I think you guys know more or less the drill, but I'll just remind you. So you can go all the way up there and then questions. And then you can ask any questions for this panel. So the panel is around the AI of tomorrow, but let's try to keep it a bit not as fluffy topics, but a tiny bit more toward the technical side. Yeah, so even if you have no idea what to ask, just check that section because maybe there are some questions that you're interested in and you can just upvote those questions. Also, there are no rules here, more or less. I mean, we'll take any questions that's on the top. And for the debate, we also have the speakers from today, Amira, Diana, and Leo. Orlando is having some technical issues, but hopefully he will be able to join us very soon. And just for you to know, guys, this pretty much covers 4 different time zones and 3 continents. So I think that's also quite amazing. And yeah, let's just start right into it. And maybe I'll just go ahead and start with one of my own questions, quite generic. So a warm-up one. So you guys all come from different backgrounds and work on a different topic, which is, I think, super interesting. And from your perspective, so what do you think will be the impact in the next 5 to 10 years of the field that you're working in right now? And what should be the industry professionals be preparing for? Feel free to go full technical on this if you want to. And anyone can jump into the question. If not, I'll pick a random one. Diana.
Sure. Well, I guess I tried to give you a hint of what I think it's to come, and some of the challenges that we're working on. So I think we're going to still be heading for this general algorithm that is trying to automate this process of finding solutions. How 5 and 10 years, it's not as much of a, I guess, span in terms of, I guess, creating artificial intelligence. So I'm not sure we're going to be all the way up to that, but I do think now we have algorithms that are really able to deal with complex structure, computational nature kind of structures, and especially the ones where we do have some knowledge about the fields and the knowledge that can go into designing a good simulator, something that we do now with protein folding, or something in terms of physical interaction, quantum mechanics, quantum chemistry kind of things, where we have a lot of knowledge in the field and can simulate some of these environments. Those are, I guess, areas where we can now bridge in some of the algorithms that we've developed just for games. More on the research side, I think scaling up to more complex tasks in terms of transfer, incremental building up the capabilities of our agent, and going into a more continual learning where the agent learns online these things and learns to explore online is what we will be heading for. But I think in terms of the industry application in the 5-10 years, I think those kind of problems, the I guess AlphaGo kind of generalization problem, very large computational state space, potentially very large time horizon in terms of planning of the interventions there is, and of course the ability to have a good simulator to play out these rollouts in and optimize the policy there. I think these are the kind of scenarios that we'll see a lot of traction in the next years.
Okay, thank you so much. Leo, what's your perspective?
So I think that in 5 to 10 years, the biggest change that I think is going to be relevant for a lot of us is that these technologies are going to be a lot more mainstream. So I like to draw an analogy to databases, which in the 1970s and 80s were a really specialized skill. There was a special job called a database administrator, right? Today we have all these specialized job titles related to machine learning. And I think that that is going to increasingly become just part of how people use computers. And I think that the distinction between a typical software engineer and a research scientist is going to continue to blur, and that a lot of the things that are difficult today are going to become a lot easier. Like I think in 5 to 10 years, nobody's going to be spending much time thinking about hyperparameter tuning like this, because I think those tools are just going to get good enough to be automatable. This was a goal of mine, when I started at Amazon many years ago, and we didn't get there, but I see a question about could we all collaborate and share data to make this possible? Absolutely. Like I think the OpenML data set is a step in the right direction, and I've been talking with folks about expanding that to include private data sets in a secure way such that we can collaborate and save energy. I think all this stuff is going to get easier, right? GPUs are becoming more common. No, people don't worry about installing CUDA kernels, CUDA drivers much anymore. It's and that's what I think is the biggest change.
Okay, Amira, so how does this look like from the perspective of quantum machine learning? I know this is a very difficult, especially a very difficult question for you.
Yeah, it's one that I get asked quite a lot, and it's difficult because the answer in short is we just don't know, right? It's anyone's guess at this moment, and it's very dependent on hardware. But what I like so much about quantum computing is that it's bridging the gap between academia and industry quite a lot, because we're seeing a lot of investment in research from industry players. And so it's really like, I mean, I'm a good example, right? I'm a PhD student, but I'm working in industry for IBM. And so there's a lot of collaboration there that I really like seeing. And I feel also a while ago, the quantum machine learning and quantum computing industry was very segregated, where you have people that are theorists and you have people that are experimentalists, and this was it. There was nothing in between. But now with this age of these variational circuits that I mentioned, these parameterized quantum circuits that work on hardware today, quantum machine learning engineers are coming from all kinds of backgrounds trying to make these things work. And so I think like in the next 5 to 10 years, we'll see a lot of exciting applications emerging from these things. And yeah, I'm just very excited about the next, I'm hopeful to see meaningful applications in the next 5 to 10 years.
And what do you think would be, so when do you think this is going to become, how should I put this question? When do you think this is going to become interesting for the mainstream industry? So I'm not talking about IBMs and Amazons and et cetera, et cetera. I'm talking about, let's say, more medium-sized businesses.
Yeah, so I think it already is, and I do a lot of work on with medium-sized enterprises, and specifically financial companies are very interested in this, right? And a lot of people also worried about cybersecurity are looking into quantum computing. But I think if you have a research house, no matter what size your company is, this is important. And what's nice is that these big industry players are making these quantum devices publicly available for you to do your research, right? So IBM has quantum computers in the cloud that you can play with right now and run experiments on. And it's just a matter of finding an algorithm that applies to your business and whatever model you're looking at, and improves it or gives you something different, right? And there are already specific examples of this in quantum chemistry, and very small quantum machine learning models that show a lot of promise. And so I think it's just a matter of scaling up qubits in the quantum computer. And then we can start to really do some cool stuff in all sizes of firms.
Okay, thank you. So we have the first question from the audience, and I think it's actually an interesting one, taking into account that you guys are all coming, like you all work with new emerging technologies, and you really stay up to date with the current state of the art. But this question, it goes more something like this. So it seems that there are huge focus on new emerging technologies. That's what we're talking about. But what about data science literacy? So it seems that a lot of business units are still living in the old world. And how can we bridge this gap? Maybe Leo, do you want to start?
Sure. I think that it's easy for those of us here who are all on the cutting edge of this stuff, in that we're interested and diving deep into understanding it, to overestimate how easy it is to deploy this stuff in practice. And so I think I guess I would defend the those who appear to be stuck in the old world to a certain extent, and say that a lot of the slow adoption in industry and government and what have you is appropriate, as these technologies aren't mature enough necessarily to deploy. There's like computer vision can be fooled by adversarial examples, and this could kill people very easily. Standard decision-making problems perpetuate biases in gender and race, and cause all sorts of other social problems. We have some hints about how to deal with all of these things, but we're not there yet. So I think I'm not worried about trying to get the world on board with this stuff faster. I actually spend more time thinking about the opposite, which is how to calm enthusiasm and make people be realistic about the limitations of this technology.
Okay, thank you so much. Amira, do you want to take the next answer maybe?
Yeah, I totally agree. So I actually used to work in asset management for a few years before I had a midlife crisis and decided to go back to academia. And in my time there, I spent a lot of it studying machine learning on my own and trying to motivate to the company at the time why we should look at it and why it was important. And it is extremely difficult in some sense, especially when people don't understand what machine learning actually does, and it's this blanket term for all these wonderful, amazing things that you can do. But trying to motivate proof of concepts and small examples is actually really difficult. And especially here in Africa, we still have this problem where we have so many other things that are more important to look at than these AI models and stuff like that, because that all comes later on. And I think if you're an individual data scientist sitting at a company, you're pretty much alone, right? And you have to upskill yourself, and you have to somehow demonstrate some value to your business. So you need to find a niche problem, something that you know that your boss or your manager or people will find important, and show them that a machine learning algorithm can help you and build this. And thanks to all this free stuff that we have online, we can do this. We can train models very nicely, and we can come up with things that we can demonstrate. So yeah, that would be my advice, I guess.
Thank you. Diana, what are your thoughts about this?
Yeah, I agree with both of the speakers. I think it's, I would actually argue as a science field or technology field, we actually are moving quite fast into cutting edge research to production, probably a bit too fast. If you think of other areas like physics, like medicine or something like that, the gap between cutting edge technology and the research that they're doing right now into a drug production or a protocol that actually is developed and mass produced is a lot larger than what we give these models in terms of time to mature and stress test. And of course, I think just because of the age of this technology and how rapidly it has already entered a lot of the areas, especially with the big companies now recognizing that this is a thing, and a lot of the products that they and services that they provide will have some kind of machine learning component in there. I think we're just moving almost too fast. There are, like, as I mentioned, like at the end of the talk, there are real problems in terms of like ethics, explainability, safe exploration of these mechanisms into the world that we just haven't caught up with actually exploring and implementing even legislation around it, and how to test these things properly.
Okay, thank you so much. I think that was actually a very interesting input from you guys. And I think this kind of follows up the question. It's especially yours. I mean, basically all of your replies. So that stuff is moving now really fast. And then there's the next question is, what's the biggest challenges of AI of tomorrow? Is it technical, or will it be a legal one? Because like Justiana said now, like if you look at medicine and if you look at other fields, there's like this, especially for medicine, right? There's this big gap of like when you find out something and until you can put it into production, let's call it this way, you really have to run a lot of trials and tests, and sometimes it takes years. So how do you see this in tomorrow? May that be in 1 year or 5 years? Is there going to be some kind of more legal limitation to this or not? Amira, maybe you can start this time.
Sure, yeah. So I always like to say that, you know, technology is amoral, right? And it's always the people that use them that make good or bad decisions, right? And so I think even if we have really good legislation in place, people will always find a way to do good and bad. And that is just how the world works, unfortunately. But of course, we can still try, right? We can try to develop legislation and things that are appropriate. But I personally, I just don't know how, and I'm actually guilty of hardly looking at ethics and thinking about ethics, because the theory is just what interests me. And yeah, to be honest, I'm really bad at this, and I'm probably a bad person to start with. But I think that whatever is going to happen is going to happen, and we just have to try and cover our bases as much as we can.
Well, actually, just before next week, just to comment is, I think there's also another question here that we can maybe put it on the table or discuss a bit later, which is then whose role is it to look at it? Is it the person who's developing those models or whatever, the technology, or should there be another, let's say, legislative shield around this or not? That's also a good question, because I remember I read an article already a couple of years ago. There was don't remember quite well the details, but it went something along the ways that somebody developed a model for giving out help in the US. And then there was one lady who was cut off the financial help she had. And then the guy just didn't know how to explain it, because he didn't know what decision the model was based on. And then when they talked to the data scientist who developed the model, he said, yeah, I should have probably looked into this, just as probably I should have dusted under my bed. So yeah.
There
Diana,
are so
maybe you
many
have more thoughts on this question as well?
There are so many examples of this where bias comes into play, right? And this has to be thought about. And we do try to think about this here as well, especially when things in race and inequality are very important and sensitive topics. And whose job it would be, I honestly have no idea, right? It definitely has to be someone who understands both sides of the coin, someone who understands the technical implications, but also the social ones. And it's a really difficult question to answer.
Okay. Diana, do you want to take a shot also at this question?
Sure. I just want to echo, that we are by nature interested in more the technical problem rather than the ramifications in the real world. That doesn't excuse us, but it's our area of research in a sense. It's our strength. For instance, for us, whenever we are taking on a new project or something that would impact the world, or we decide to release something to the world or take a problem that we will tackle, we have an external team. I mean, it's external to research, but it's still in DeepMind, that looks at ethics in society and the implications there, both morally, ethically. We have a charter that tries to have some values in place where we try to make ourselves accountable of the potential implications that this technology would have. And these are people that, you know, come from different backgrounds that are not, you know, our technical backgrounds. We're very good at our job. They are very good at, you know, like social models and trying to, you know, predict what would happen with these particular instantiations or these particular interventions that we're considering doing. So it's a different set of skills in a sense, but it has to be part of the process of I guess deciding, at least when these things go into the real world, into an application, we if the government bodies do not catch up by that time, I think we as organizations, we have to be responsible or take some accountability for that.
Thank you for your perspective. Leo, do you have a different opinion? Does it go in the line as these opinions?
Yeah, I agree with what Diana and Amira said, and I'll add on to that I personally welcome legislation in this space and think it is overdue for things like facial recognition. And there are certain industries in the US, at least, that are already regulated about their decision-making processes. And I think those legislations need to be updated. Legislation is necessarily slow-moving, but a lot of it revolves around explainability and interpretable models. And that's really, really hard for cutting edge, modern techniques like neural nets. And I think legislation would be better aimed at ensuring fairness and eliminating bias, because I think that's easier to measure and probably going to be easier to accomplish in the future when the techniques evolve a bit more, but they're still not very good. And I'll say that in an absence of regulation, which is where most of us are working, I think that we as researchers and practitioners need to think about the potential for negative impact of the work that we're doing. And that varies a lot depending on what you're doing. If you're doing quantum ML research, this stuff is clearly a long way from being used for real world decision making. And so it's probably not that important for QML to think too carefully about ethics. RL is further off, but it's getting closer. If you're doing pure computer vision research, you might excuse it and say, all I'm doing is pure research. I'm just building a better ImageNet model. But that ImageNet model, if it's got a racial bias, it's going to end up being used by thousands of real world practitioners. And it could have some pretty significant impact on real people's lives. So I think everybody, especially in an unregulated environment, is responsible for thinking about the potential of abuse of their own systems and how to counteract that. And this is something I worked on a bit at Amazon, and I'll say that there's a common perception that when the data is biased, the models will reflect that bias. And so the way to fix it is to fix the data so that it's unbiased. And I'll just say that that's not the only way to do it. There are algorithms out there which are variations on training algorithms which can ensure fairness, even with an unfair data set, according to certain criteria. You can do things like include race and gender as sensitive variables in the training process and have the training process ensure that the model that comes out is equally bad for males and females and for white people and people of color and things like that. And these kinds of techniques, I think, if you're not aware of them and you're working on anything that is affecting real people's lives, you should go learn about them and figure out how to deploy them in your practice.
Then maybe I can have a follow-up question for that. So do you think that also there should be some kind of subjects? So if imagine now there's a lot, at least in Portugal, there's a lot of masters popping up in data science and whatnot. And do you think that there should be some kind of, I don't know how to call it, ethics tracks or something like that they learn while they're studying this subject?
Yeah, I think if you are a dean of a university, you should require that everybody graduating with a degree in ML or computer science has a class in ethics. I think it's so important. we can accidentally do a lot of damage, and we can also improve things, right? It's possible to automate certain decision-making processes in theory in the future, where currently biased humans are perpetuating stereotypes, and it should be possible someday to eliminate those biases by carefully designed algorithms.
Okay, thank you so much. Okay, so let's jump to a bit more of a bit of a different question. So the question goes like this: it's new computing techniques help only on data processing or also on data representation in order to have a better fit in the real world complexity. Diana, do you want to be the first one to jump on this? Did you understand the question?
Sure, but I'll have an interpretation of the question. Is
because I think that's what they mean with representation, in the sense that if you can represent real world into some kind of model, I guess. I'm not sure if it's that or not.
Yeah, not sure. Like if I see the difference in a sense of that's all we're doing. Manipulating data into basically a representation that is more manageable for the models that we train on top of that. Usually, that's a representation that is that enables, let's say, better generalization properties, or like throws away a lot of the information that is not needed in order to focus on the things that are useful for the prediction. I'm not sure necessarily that data representation is necessarily interpretable or visualizable in terms of our data representation or the representation of that process. But in a sense, all I guess methods out there, or both supervised learning and functional approximator methods will learn some representation of the data that tries to play well with the prediction problems that we have ahead.
Okay, thank you so much. Maybe Amira, because this also, I think quantum machine learning here can have also something to say, because you can really, when you talk about when you talk about quantum computing, you really represent even things kind of in a different way compared to a classical computing. So what's your opinion?
Absolutely. I really love this question because it is something very relevant and something that I'm thinking about as well. And how one encodes data into a quantum computer is mapping it into a different space, right? It's mapping it into this exponential Hilbert space, which I spoke about. And there are many different ways to do this. And in fact, you can embed your data and you can actually train this embedding. So you can entrain this feature map into in quantum Hilbert space. And I think this question is still open, right? Like nobody really knows what is an optimal quantum feature map for a specific task or an optimal representation of your data. But what we do know is that like things in chemistry, for example, just we can't even think to model them on classical hardware, right? Because there are so many interactions, there are quantum mechanical effects. But encoding them onto a quantum computer and processing them there is definitely possible. So now we can start to model different things. We can start to look at things that we could never look at before. And this is really exciting for applications like material science. And in quantum machine learning, combining these, like training how to embed this information into a quantum state. Yeah, I just think it's really exciting. And I hope that we can get more out of this, that we can see more, or get more information from this in quantum computing. Yeah.
Okay. Thank you, Amira, so much. Leo, what about you? What are your thoughts? I think you're muted or your mic is not working. One of the two.
Sorry, my laptop just like went to its lock screen as I tried to unmute. Apologies. Question. I'll try and answer what I got a question, which is about how to represent data in these systems. And I'll just say briefly that I think there's a lot of opportunity for innovation here. I think we understand well how to represent images, and text is, like Jan LeCun kind of figured that out for us, and in the 90s, and text is perhaps still evolving. Subpieces seem to be dominant these days, but who knows how long that'll win for. I think learning to represent chemicals, for example, as Amira was talking about, or people or cities or what have you, that there's a lot of opportunity to have a big impact and change the way people do things by coming up with novel ways to use data in these systems.
It's kind of like, actually, lately I've been reading a lot, for example, on graph nets. This is maybe a good example of, let's say, how you can represent data a bit differently, or how you can think about the different representation of data. And maybe connecting to something you mentioned, not in this question, but in the one before that, which is about the regulation for facial recognition. Actually, the most ordered question now is, how should we as a community deal with deepfakes, or what could come from deepfakes?
I'll talk. So I think this is an unavoidable thing that is in a very dangerous phase right now. So the ability to alter video and make it completely realistic on the output is right now in the hands of Hollywood studios with multi-million-dollar budgets, and motivated individuals can replace faces on video and make deep fakes with non-trivial compute power. Like, these GPU hours still cost a meaningful amount of money to do this, and it takes some skill. That skill is going to go away. It's going to be a standard, program you run on your phone in not very many years. And people are going to learn that just because they see a video doesn't mean something actually happened. Just like 100 years ago, if somebody read something written down, they were pretty sure is true. Nowadays, reading something, you don't believe it's true at all. I think the same is going to happen for video, and not very long. But we're in a really dangerous time right now, where the ability to modify things is not well understood, and there's a lot of opportunity for problems. So last Halloween, I created a toy project I called the Monster Mirror, which took people's faces and replaced them with animals and monsters, and put it up live in front of my house for trick-or-treaters. And I thought very carefully about the license under which I released this into the open source, and wrote a custom license, which I know a lot of people say you should never do, but it said this can only be used for live performances, and you can't record anybody, and if you transmit it, you need to get written permission from everybody involved, because I really, really didn't want this tool being used to promote or enhance deep fakes. And I think that, again, this is a responsibility for all practitioners to think about, is how is your work going? How could your work be used negatively in the world? Technology, as Amira says, technology is amoral. It's not good or bad. But I think we should all be careful as leaders in this space to think about minimizing the harm from what we do in likely circumstances.
Thank you so much. Diana, what's your take on this? Maybe just even before, just maybe one thing that you mentioned, that it's also you couldn't trust everything you read, but even a closer example to the younger one, a bit younger ones, let's say, maybe it's that also you couldn't trust pictures at some point when Photoshop was a big thing. There was a lot of, there were fakes as well, right? It's just, it was not moving. It's the same concept, more or less. Yep. Diana, what's your thought?
Yeah. I think, yeah, the same train of thought, I guess, of we would just need to shift the mentality of this is possible, and people to be aware that this is not the hard proof evidence that used to be, or this modality can't be tampered with in a sense. It reminded me that yesterday I was viewing an apartment and trying to take pictures of like some of the spots on the wall and stuff like that. And when I tried to send them to the real estate agent, I realized that my camera filtered those off. It completely removed all the inaccuracy there, and it's like, now I don't have proof of this. but I understand the mechanism behind it, and I can switch it off and stuff like that. But it's in a sense already happening. It's more educating the people that this is something that will continue to happen, and how to trust these I guess mediums of information moving forward.
So, Mira, now imagine that this deepfake in the era of my quantum machine learning, it's even way easier and faster to make. So maybe you can even do something live. What's your take on that?
Oh gosh, I actually can't imagine it because the state of our hardware is so bad, right?
Well, let's imagine a perfect world, right? Let's imagine we can get to the absolute zero like this. And
yeah, gosh, this is really a difficult one for me, right? Because I'm a big fan of like all these misanthropic animes and all the stuff where the world is going to end, and I'm always on the side of the machines. Even in the Matrix, I was always like rooting for the the machines to win, but parts of me, I mean, is on the side of humans. So if I had to imagine this technology to exist, I just really hope that we reach a stage as individuals in this community where we really start to care for each other. I mean, I think even in now this pandemic and in this COVID era, I feel it here that our country has gotten a lot closer because we have to stand in solidarity to fight through a common enemy, right? So to think about a bigger purpose and to come together. And so when this technology comes about, I hope that we all mature as people and grow together as a community, and we have strong foundations in place of what is right and what is wrong. And if people want to do something bad or silly or stupid, then this is immediately like neglected and not considered. And yeah, I'm very hopeful and perhaps very naive in this space, but let's see, I guess, what happens.
Okay. Thank you so much for your answer. So now, okay, this is going to be a bit more meta. And you're like, even more than the questions before. So how do you think that AI and machine learning will shape our future? So in the future, are we going to be stripped of our decision capabilities? And is there going to be some kind of big brother? Or are we going to have, let's say, even augmented decisions, and we'll be in control of our decisions, but just we'll be able to make them better? Maybe Amira, since you haven't started in a while.
No, I was hoping you wouldn't pick me. These questions are so difficult for me because I normally answer things like, what is the quantum state after you apply a rotation or something, right? These are things that I that I can understand and answer.
Well, this is, I think that also, just let me maybe just jump in. I think that this is also how maybe you should think about it. It's how you see the field, in which direction do you see the field going, and what's your gut feeling? Because I really think that not even the best machine learning algorithm can predict, like the current state of the art, at least, can predict what's going to happen in the future. So more about gut feeling and why you have that gut feeling.
Absolutely. No, I mean, it's super important to think about, right? And I don't know, I don't really see our world changing too drastically, right? So I think all these kind of innovations and these technologies will improve, but this will be systematic, and maybe some of them will be like wow at first, but then we acclimatize as people, right? So I don't see a massive leap anywhere yet. Even with quantum computing, people often ask me this, like, if we had a quantum computer tomorrow, now would all our problems be solved, or now what can we do? I don't see any of these technologies really, like even reinforcement learning, even so reinforcement learning, neuromorphic computing. Okay, I don't really know too much about neuromorphic computing, but I don't really see them as being totally disruptive to our everyday lives. And I think they will bring very nice opportunities. They will bring very cool things, but they're all things that we can acclimatize to and probably will become desensitized to eventually. So yeah, I don't see AI and ML disrupting us too much, if that's an answer.
Right. Leo, do you want to jump in?
Sure. Yeah, and I think I agree with Amira that I don't think there's going to be dramatic, sudden disruptions. That everything is going to take longer and be more gradual than we thought 5 years ago. I think a lot of people would have said nobody would be driving a car today in 2020, right? That it would all be fully driverless. And that obviously hasn't happened. It's a long way off. One thing in terms of people's lifestyle that I think is going to happen is that bugs are going to become more and more present everywhere. My family, we spend a few minutes every day arguing with Alexa about something. Trying to convince her to play a certain song or video or to stop a timer or something. That kind of thing, I think, is just going to get more and more prevalent. You're going to be arguing with your dishwasher or your washing machine, and it's going to try and be helpful. And 80% of the time, it's going to be great, and then 20% of the time, you're going to want to throw the thing through the window. And I think those are, I think, how a lot of real world AI is going to alter people's lives. Is things are going to kind of get easier, but also more frustrating and annoying.
And maybe Diana, you want to jump in also on this question?
Okay. Now, I think for the first time, I'm going to disagree with Leo and Amira. In a set, like just trying to be the devil's advocate here, at least for the kind of research that we are doing, I do believe if we were to actually reach our mission and have this general purpose algorithm, I think that will have massive implications in our society. It's not necessarily the things that you think of ML already being in right now, like our computers, recommender systems, even like smart homes and stuff like that. I think the potential of these methods going into enhancing our abilities to investigate and come up with better solutions to like science problems and like massively speed up our endeavors there, that will open so many opportunities for us. Like even something small, like just niche, like protein folding, like just branching out there into other areas in chemistry, in drug discovery, like just the capability that the augmented capabilities that we could get out of these methods, I think would almost surely revolutionize the way we live our lives. I think this will change the face of our I guess existence moving forward.
But going back a bit to the original question, do you think that we're going to be stripped of our decision capabilities, or are we going to have augmented decisions?
I think like with all of the technologies that we've seen so far is an augmentation of our natural capabilities. That's never going to be like, these systems will never, be something that will run, I guess, our environment. It's providing us with a solution, and we'll still have to, go in there and understand the solution and how to implement it into the real world. It's not that we're gonna rely necessarily on that automation per se. At least in the problems that I was describing, it's more. This is a new protocol. This is a new method of doing this particular molecule or this particular drug. You can try it out. It's almost narrowing down the search. What we do now by generations of scientists, by generation of grad students that look at this problem for like 30 years to get an understanding of that particular a molecule. Now we can spread that out into this very rapid computational process. That's where I feel like it's just, again, enhancing our capabilities of doing this decision-making process.
Okay, thank you so much. Let's go to something a bit more down to earth. I mean, still in the meta field, but a bit more down to earth. So AI in our future criminal justice system. What are your thoughts? Fears and advantage of its use. Do you think these two fields need to be separated somehow, or should it be somehow linked for a greater good? So should AI be basically applied in the criminal justice system? I think that's the basic question. I don't know, Leo, do you want to go first?
Sure. This is a super interesting one. I can see really strong arguments on both sides of this. I think that I'd say the first thing to do is I think we should be cautious, but I do think there is potential. So as I expect y'all know, the US has been in turmoil lately over the bias in our policing system. The racial bias in particular. It's torn the country apart with good reason. Our police are racist, broadly speaking. And as I mentioned earlier, I think it is possible with technology to eliminate that bias, right? If you had algorithms issuing traffic tickets, then you could program those algorithms to not pull over Black drivers more than white drivers, and that would absolutely fix that problem. So I think there is potential in that regard, but I think we have a long way to go before we can realistically start deploying those kinds of solutions. And in the shorter term, I think caution is super important, and the workload of judges isn't so high that I think that we should be like algorithms for estimating sentences or what have you. Again, maybe there's potential here, but I'd say any application needs to consider bias and reducing prejudice as its primary goal, much more importantly than reducing workload or making anything more efficient. I think that's the only way that any good comes out of this.
So you said that there at some point it could be applied, but we're not there yet. What would you say your threshold is?
Well, I mean, deploying computer vision in the real world has huge safety implications, you know, as long as adversarial examples haven't been solved. I don't think we really know how to eliminate bias from nonlinear algorithms. So, you know, neural nets are still pretty tricky to make fair. Things like that. I don't know everything needs to be done, but there's a couple things.
Thank you so much. Diana, do you want to jump in on this?
Yeah, I do think it's a very interesting question. I'm not sure how much I can add. I was just thinking that I guess justice system it's a hard problem that humans haven't solved. I mean, throughout nations and stuff like that, we haven't agreed what the just system is, what the just penalty for a particular action is, and how to have a unified, I guess, process of the steps of reaching a verdict and reaching a decision on that. So I think even articulated what the optimization process there is might be quite hard and problematic. I would also echo maybe that all of these methods at this point are somewhat, should be at least used more as a augmentation of our capabilities, in the sense of like, this is an advice. This is, you know, if you do image recognition and it's flagged as, you know, a person of interest, you don't necessarily go in and arrest the person. It's more like, these are the potential, I guess, sightings of this person. We can act on that information. It's not. I think it's coming from a bias that we had with computers of being this exact thing, that we trust the information that the computation provides, which is, you know, the old kind of AI rule-based and like recipe-based kind of computation. This is stochastic. This is statistical kind of learning. So it's It's not trusting that, you know, the system actually knows 100% of that answer, like knowing that this is like the I guess the process behind it, and the uncertainty that comes with that model.
Thank you. Amira, maybe just last quick comment before we wrap up.
Yes, sure. I'll say two things. So one, I wish I knew this was going to be such a heavy ethics talk, because then I would have faked technical technical problems and not come as well. But two, I agree with both Leo and Diana, and I'll maybe just paraphrase what they say, because I feel like I'm in the middle here. And again, I'll relate it to one of my favorite animes called Psycho Pass, which is set in the future. And what happens there is, like, technology is so advanced that eventually it just starts to make decisions for everybody, right? So as soon as you're born, you are immediately classified as a criminal or not and put into prison. You already know what your optimal job will be. You already go and you follow this career path, right? So there are two sides of this. Like, as soon as we open the door to start introducing technology to help us make these decisions and remove these biases, then at what point do we stop, right? Because now we've already got technology, you know, as Leo said, like deciding who gets a traffic fine, but then also like flagging people for persons of interest. And then how far does this then go, this technology? So on to Diana's point, you know, we have to very much use these things as ways to inform us and give us information and enable us, but ultimately the decision stays with us. So yeah, it's a tough one.
It is indeed. I think that there is going to be a lot of interesting discussions in the upcoming times also about how we apply actually these algorithms and where. But I just want to add that maybe that's why we're having so many questions, because these are not the questions that we as the SPT come up, but this is the questions that the public is asking that are voting. So I think this is also very interesting for other people. So guys, we're going to wrap up here. We're already a bit over time. Thank you so much for coming. So just I have one last question, and I saw that question was removed, but I'm still going to ask it. Leo, what's the brand of shampoo you're using?
Boy, it's a really cheap one called Tresemme. My goal is to not pay too much attention.
So see, now the problem is solved if you guys want to have a great hair as Leo. All right, guys. Well, thank you so much. I think it was a wonderful day of learning, and thank you for all the effort you guys put into and the time you took to coming here. I also know that it takes some time to prepare these things and to be here and to pay attention, and you need to juggle around with plans. So thank you again from everyone. I think when I'm talking for myself, for the organizers, and also from all the participants that have been watching you guys live. And I think now we're going to go in just a couple of seconds to the closing session. And if you guys want to stick around, we're going to have a virtual party after. So enjoy. See you in a bit.